talked about. Our next presenter, and I think it's the last in the series of regular presentations, is Dr. David Rogers, presently at the Missouri University of Science and Technology, who's had some most interesting interactions with Ralph Peck over the years, as I'm sure he's going to tell us. Thank you, Dave.
Well, I'm going to focus on the early years of Ralph Peck's career, because when I started interviewing him years ago, he was looking back on his life, as you do when you get older, and seeing just how phenomenal it was, the people that he was exposed to early in his career when you're most impressionable. And he says, as one of the previous speakers said, you can have 1 year of experience repeated 30 times over, doing the same thing over and over, and that's not the same as 30 years of varied experience. And one of the things that Ralph said, if you ever listened to him, he always felt it was good for engineers and engineering geologists to work at least 3 different places during their career, so they could see that there's many different ways of solving a problem. And what clients actually hire us to do is not to do engineering calculations. Clients hire us to solve problems. And just like a marriage counselor, you need to sit down, shut up, and ask clarifying questions at the beginning of a project to really determine what it is that the client really wants and is expecting. And I know I made grievous errors in that early in my career until I started working with Ralph, and he started critiquing some of the things I had done, and I learned that I needed to be a better listener. And sometimes clients have unrealistic expectations, and if that's true, you need to tell them that right at the outset so that they aren't disappointed when you get to the end and you deliver your product to them. So who had the most influence on Ralph? Far and away, he said, his father, Orland Peck, who was a civil structural engineer with the Denver Rio Grande Railroad. He worked for a whole series of other railroads before landing in Denver in 1921, and he worked for that same railroad company from 1921 till he retired in 1956. And that's him up there climbing. Ralph took the picture. That's his dad on a Saturday up on a bridge looking at a riveted connection on a railroad bridge near Denver. That's what they did when he took his son out, and he would show him what he did for a living. This is their home on Garfield Street in Denver. That's where he spent his formative years, living with his parents. He was an only child, and with his mother's mother, his grandmother. And years later, Carl and Ruth Terzaghi came there to do some consultations for the Rio Grande Railroad, both of them. Ruth working on alkali aggregate reaction problems, and Carl working on the squeezing in the Ranch Creek Fault Zone on the Moffett Tunnel. This is what it looked like inside the home. Ralph was named after his mother's brother, Ralph Hike, see there on the left. This is the family, his mother on the left, in the picture on the right, and his father and grandmother, and the piano there that Nancy was telling how he loved to play the piano. He and his father both played the piano by ear. And one of the first things he did when he went to Harvard is he bought a piano very inexpensively because it had a broken soundboard. And he, being an engineer, he fixed the broken soundboard with some Will-Ho glue and some C-clamps, and got it for a very bargain price. His first exposure to soils, I asked him, you ask when somebody gets older, you ask them a series of questions. And of course, if he's a geotechnical engineer, I'm going to say to him, well, where was your first exposure to soils? And Ralph would always chuckle, and he'd sit there, and he'd see him thinking, and he'd look up kind of at the ceiling, and then he'd say, well, my first exposure to soils was actually as a junior member of a signals gang. And I'm going, signals gang? What is that? Well, that's a bunch of guys that go around on the railroad, and section gangs and signal gangs work on the railroad signals, and it's a lot of digging. And he wasn't very good at the digging, and the guys made fun of him, saying he was a patsy. And during that summer, he worked on his muscles, and he worked on his shoveling, and he finally got their respect by the end of the summer. He's making 55 cents an hour, and after he finished his doctorate 7 years later, he got 75 cents an hour. Probably shouldn't tell that to you if you're college students out here. He decided to go to Rensselaer Polytechnic because his dad said that's where the great bridge engineers went, and he wanted his son to have the benefit of a great education. His father had graduated from Wisconsin, and he had turned down scholarships at Colorado School of Mines and other schools, the University of Colorado, and his father felt that that was the place for him. His father didn't actually ever visit the school till the day he graduated 7 years later with his doctorate degree and got married. He would come home during the summers. The first 2 summers he had surveying camps. He would come home for a month and he had to write a term report. The first year he did a report on Cheeseman Dam. This shows one of his trips home, 1931. And in late July 1936, for the family vacation, instead of going to the Rockies, they went all the way out to San Francisco to see the San Francisco Bay Bridge and the Golden Gate Bridge under construction, because that's what his doctoral dissertation was on. It was on suspension bridges, working with D.B. Steinman, and so it was a thrill to get actually up on the top of the Golden Gate Bridge and to look down from the tower. He and his father both went up there and got to see these monumental projects under construction. He says that was the thrill of his life up to that point in time. His father then engineered a position for him at American Bridge and Iron in Ambridge, Pennsylvania. He took a short course there because the Denver-Rio Grande Railroad had contracted 11 bridges to Ambridge, and that was the only work they had going in the Great Depression, and so he actually ended up working there for 10 months. But they were 10 critical months. He also designed 3 bridges for his father. This is one of them on the Animas River while he was during his senior year of college. He got his doctorate awarded. It was only the 3rd and 4th doctorates awarded by Rensselaer, 1937. He and Bert Engels together working on the same project. He got that in the morning, and in the afternoon he married his longtime sweetheart, Marjorie Truby. And then they had a 3-day honeymoon before he had to head for Ambridge, Pennsylvania for the job with the bridge company. His dream was to work for a name bridge concern in New York City. And the only one he knew had any personal connection were D.B. Steinman and Shortridge Hardesty, because Hardesty was a 1906 graduate of Rensselaer, and he would come up there once a year and give lectures. And he was the inventor, or more or less the guy of the lift span bridge. That's what Waddell and Hardesty were famous for. They were based in New York. So Ralph kept writing to him and asking for a position there. And after he got laid off at American Bridge and Iron, he talked to L.E. Ginter, who was working he was the first PhD in civil engineering at Illinois, and he was teaching then down in Texas. And Ginter said, well, I'm going to move up to Armour Institute in Chicago, and I need somebody to teach soil mechanics. Do you know anything about soil mechanics? I don't need anybody in structures. And he said, well, no, I don't. But he said, well, if you can go learn some soil mechanics, I might be able to find a position for you. So he wrote to Arthur Casagrande, and Casagrande wrote back and said, I prefer to have my students come in the fall. They have the regular progression of things. But Peck was out of work April 1st. So he ended up sending a letter to Casagrande and said, I'm coming to Harvard, whether you like it or not. And 2 days after he mails that letter, and he's in Ambridge, he gets an offer of work from Shortridge Hardesty at considerably more, $1.16 per hour, considerably more than the 75 cents an hour he's getting. And he turns it down. He said, that's his dream job. I said, how could you turn down your dream job? It's just, can't you write a letter back to Casagrande and say, no thanks, God, I couldn't do it. And he says, no. He said, I felt this is what the Lord's directing me to do. And I'd made a commitment to him that I was coming. I didn't realize how upset he was going to be with me for coming late in the term, but that's what I decided to do. So that's where the major fork in the roads of his life. Who does he meet at Harvard that really saved him? Bill Shannon and Ralph Fadum. He said, literally, these guys saved me because I didn't know what Casagrande was talking about coming in mid-April, more than halfway through the spring semester, and I was able to take Bill Shannon and Ralph Fadum's notes and work real hard every night and try to catch up so that by the time he got to finals, he actually did pretty well, much to the surprise of Arthur Casagrande. And of course, you hear all sorts of wild stories and interesting stories and colorful stories about Casagrande. And I always asked I said, Ralph, tell me about Arthur Casagrande. And he'd always say, Arthur was a very complex personality. Well, here's a great picture I got from Bill Shannon's son. This shows Stan Wilson on the left, Bill Shannon in the middle, Arthur Casagrande. This was his inner sanctum group in 1938, the year before Ralph got there. Ralph was able to break into this inner group. These were his lab assistants, and they were the ones that did lucrative consulting work with him, and they also built the soil mechanics testing equipment. And what they found about Ralph was Ralph had a structural engineering background and years of drafting experience. And so they asked him to draft some pieces that they were trying to build for a testing frame, and Ralph showed them how they had done that incorrectly. And they didn't have, on the two channels going back to back, they didn't have the bolt holes lining up like they should, which was very embarrassing to them and everybody who came into the lab. So they hired him to do some drawings, and Casagrande just loved his structural drawing. These are ink on vellum. That's what all he had done for that 10 months at American Bridge and Iron. Well, Carl Terzaghi sends his wife and young son Eric, he's about 3 years old, to Cambridge in the summer of 1938. He then has to start packing things up, what limited things he can pack, and moving bank accounts and things. And he finally comes in late September 1938. And the students at Harvard hear about him, but they only see him one time. He gives one lecture. And because he is working furiously with all his contacts he has with people he writes in the United States, trying to line up consulting work to see if he can stay in the United States. He doesn't know if he's going to be able to stay 3 months or 6 months, and so he leaves everything open back in Vienna. He leaves all of his books, all of his papers, all of his lecture stuff. The only thing he took out of his office in Vienna was his English manuscript of the book that became Theoretical Soil Mechanics, 1943. The guy who helps him out, two people, Al Cummings and Arthur Casagrande. Arthur says, come on over, we'll get you a title. And they gave him Lecturer in Engineering Geology. And that was his title till 1947 when they elevated him to Professor of the Practice of Civil Engineering at Harvard. Al Cummings was one of his confidants who worked he was Raymond Concrete Pile Company's lead guy in Chicago. And Raymond Concrete Pile Company really had its origins in Chicago. That's where their headquarters was till they moved to New York later in the 1940s. Cummings was a self-taught geotechnical engineer, and he corresponded with Terzaghi, and he said, I can line up something for you. I'll line up a meeting with the Western Engineers Association here in Chicago, and you can come in and tell them about the Berlin subway and the 20 guys that were killed there, and you might get some work from the State Street Property Owner Association or from the city. And that worked, except they didn't want to bring Terzaghi in at his rate. He was too expensive. They wanted him to just come every 4 to 6 weeks for a couple days. And so that didn't work out in negotiations with with Ralph Burke, who was the chief of the Subway and Traction Agency. And so Terzaghi suggested, well, could we hire a young person, a younger engineer that would be my eyes and ears and would be there 24/7 and then make daily reports to me, daily typed reports. And so he goes to work for this guy right here who is named Ray Knapp. Now Ray Knapp is an old Army combat engineer, served in the First World War. He's an Army Reserve major at this time. And look what he said about Ray Knapp. This is actually a quote. He said, Ralph said, I learned as much from Ray Knapp as I did from Terzaghi. Not about soil mechanics, but about how a geotechnical engineer can go about doing some good in an organization. He said Ray Knapp served as the consummate interface between the job site and management, facilitating whatever needed doing to accomplish the task at hand. He knew how to go to Burke and sell Burke on doing the necessary geotechnical observations and measurements, which kept growing every month through the project. And Burke would always be asking, why do you have to do all this measurement stuff? How's it really going to help us? All we want you for is to limit our liability with the settlement of the buildings. And here's Ralph actually logging his first boring. And it's being done by the Gow division of Raymond Concrete Pile Company. There's your 140-pound donut. It's using, hadn't been called the SPT test until 1947. That's when Terzaghi put that christening on it. But that's his first boring, done in mid-February 1939 outside, and he's wearing an overcoat, as you can see there. The big thing they wanted to track, Ralph Burke wanted them to track, was the conditions and the settlement along every single portion of the subway lines, because they're worried about the lawsuits they would get for causing damage to the structures. So that was what their focus was on. And in doing so, he said, the observational method really was born by Terzaghi demanding all these different observations and measurements from me that he didn't get with the Berlin subway project. He wished he had had these things, and he didn't get them there, but he got them in Chicago. Sometimes Ralph had to hire a secretary. He had to train her on the technical words. She typed reports every day, and sometimes he had to stay up till 2 o'clock in the morning because he was teaching soil mechanics at night at Armour Institute. And if he missed one day, he would get a note from Terzaghi saying, "Where was your report of Tuesday? I did not get it in the mail." So he's going out to the mail each day and looking these reports over. Some of the people he met along the way: the first engineering geologist in Chicago, a fellow named George Otto. Otto was like Ruth Doggett Terzaghi, he was a student of Harlan Bretz at the University of Chicago, getting all his degrees there. He went out to Caltech and hoped to actually join the faculty at Caltech. He worked out there with Hunter Rouse and Vito Vanoni for several years, and then when he came back to visit family in Oak Park, Illinois, in Chicago, he found out from Bretz that they were working on this subway project, and they had all these incredible exposures in the excavations of all the glacial units that he had been studying for the previous decade or so. And so he ended up quitting at Caltech 1940 and coming back to Chicago and doing his PhD on the Chicago subway project with Ralph Peck. And Ralph said George Otto was the first geologist cross-trained in modern soil mechanics. And he became a tremendous asset to Burke and Peck when they did the O'Hare Airport job. In fact, that's when he went out on his own, left Armour Research, and started his own consulting company when O'Hare Airport project started. Ralph was passed over for an assignment right as the subway work was coming to a halt with the beginning of World War II and the shortage of concrete and steel. He interviewed for a position as the chief of Soils and Foundations Division at the Waterways Experiment Station. That's because Spencer Buchanan had been recalled to active duty and had left in 1940, actually. And so he and Bill Turnbull, shown here at their interview in March 1942, they both interviewed for the job. Turnbull was about a decade older and was from Nebraska and had a lot of managerial experience. And Ralph said he was much more well suited to the task. And of course, the things he did during the war were fairly legion, because that work that he did with Pappy Porter and others out in California led to the whole design methodology for flexible pavements. Turnbull was right at the center of all that during World War II. It also led to the modified Proctor compaction test. Well, he got offered a position to teach at Illinois. He's excited about it. Whitney Clark Huntington offers him a position. Look at this guy. He was chairman of the Civil Engineering Department from 1926 to 1956. That's got to be some kind of record. I don't know how a guy could be chairman and keep all the enemies off him for that long. But anyway, he asked Terzaghi, what should I do? Should I take this teaching position? And Terzaghi, here's what he says. He says, "What? You teach? You haven't done anything. That'd be like a cadet going to the military academy in New York there, the West Point, and teaching artillery and never fired a cannon. You need to go out and work, get some experience." Well, that's so he, and Marjorie was very, very disappointed. They were looking forward to that, and so he says, well, this guy's my mentor. I can't cross him. He's like my second father. And so he says, okay, I'll just keep working here on different wartime projects. This was an ore yard, one of the ore yards he's working on. And about 7 months later, he discovers a big error in calculations on the ore yard settlement calculations that Terzaghi has made. And it's going to lead to a large bearing capacity failure here. It's going to impact the gantry crane you see here. And so he says, how am I going to show this to the old master and not make him angry? And he agonized about it, and finally he brought it up to him as gently as he could, like, I think you might have made a mistake in here. So use the easiest word he could use. And Terzaghi said, what's that? And he takes it and he looks at it and he's silent for about 13 minutes. I said, how do you know 13 minutes? He says, I was watching my watch and I was sweating. And he says at the end of the 13 minutes, he looks at me and says, you can go to Illinois now. Well, of course, the job hadn't been offered to him. It's been 7 months since the job had been offered. So he sends a telegram to Huntington, and Huntington finds, as you heard from Nancy, the 7/8 salary to cobble him through the first year. And he had no students during the war. He had 2 Egyptian students during the war, and that was it, working on airfield stuff at Rantoul Field. There wasn't a lot going on during the war. A man who was giant in his life was Ralph Burke. Ralph Burke was the most famous civil engineer in Chicago in that era. He was a head of engineer for the Parks Department. They had 22 different Parks Departments. They put them all together in 1933, 34. And then Burke was the guy they went and got to be head of the subway and traction department when they were building the subway as a WPA project, or Reconstruction Finance Corporation project, in the late 30s, early 40s. Burke went out on his own in 1951, and he wanted Ralph Peck as his vice president and chief soils engineer. And he made Peck an attractive offer to triple his salary that he had, triple it, and come to Chicago. And Peck wanted to be a teacher. And he asked Terzaghi, do you think I should take this position with Burke? And Terzaghi said, nah, as soon as Burke dies, that'll be the end of his company. Burke's company's still there. He died in 1956. Oh well, Terzaghi wasn't right about everything. None of us are. 2 of the projects that Ralph would talk about the most, if you were his student, you probably remember these, was the Chicago water treatment plant, where he learned all about differential settlement and mud waves and heave, and how long it takes theoretically versus practically to wait for settlement to occur when you surcharge a soft foundation. And then, of course, the Grant Park Garage, which was a massive project where they had the water lines freeze and break and damage the whole structure several decades later. Things that you just don't think about at the design stage. They're not in the assumption sheets of your given assumptions. And so he always liked to talk about the projects where he got surprised or he had problems, because that's where you do the greatest learning. Burke went on to envision, they had Midway Field was the city's airport, as well as the one on the shoreline down past the Navy Pier. And Burke had the vision for O'Hare Field, that Chicago needed the largest airport in the nation, if not the world, and it's going to become the airline crossroads that it already was as the railroad crossroads of America. And so this area had not been developed because the geology was so bad. It was a lot of peat bogs, and it was dairy farms because it wasn't good for building on, and so it had a lot of challenges with foundations, with geotechnics. But Burke wasn't worried. He had Ralph Peck on his team. So he sends Peck to New York to visit this guy. This guy is the most famous personage of that era, along with Terzaghi, a guy named Omer James Porter, or Pappy Porter, out of the California Division of Highways. He quit and started his own firm in 1942, and he came up with the California bearing ratio test, the original California 216 compaction test, which Proctor emulated 5 years later. This guy came up with the Porter sampler. It just goes on and on. He was a real born problem solver, but he was also an alcoholic. And so Peck goes back to visit him at his New Jersey office, and the guy's drinking martinis for breakfast. He drinks martinis for lunch. He's taking Peck out. He keeps drinking martinis, and Peck's a teetotaler, and he doesn't know if this guy's really catching all the technical stuff that he's given him. So when he gets back to Burke, he says, you want to hire this guy to do wick drains, because he's the father of wick drains too. Did wick drains on the San Francisco Bay Bridge in the early 30s. He says, I don't think we should get him on our team. And Burke, who's a much older gentleman, just laughs and says, here's the quote, "Ralph, the construction industry is filled with brilliant alcoholics. You just have to know what sets them off. And we'll have to have a plan. So if a guy goes down on us, We have some way of getting out of it. Peck is so impressed by what this guy does with the relocation of the railroads along York Avenue. And he ends up going in there and surcharging them. He puts in, you know, the wick drains and surcharges them, but then when he's done, for an extra safety factor, he takes 3 feet of soil off before he puts the railroad embankments down. So when they measured the railroad embankments, because the railroads were not hot on this idea at all. They didn't like this treatment. They had never heard of it. They didn't think it would work. They didn't get any settlement because he didn't even get out on the pre-loading. You know, he didn't get out to the pre-existing load that was on the site when he put the railroads in there. So he said, I learned a lot of things from Pappy Porter. So you can learn a lot of things from an alcoholic even once in a while. Now, tack on, 1954, 5 tunnel workers were killed in a cave-in in the Wilson Tunnel, and he and Terzaghi are called out to Hawaii. This is my favorite picture of Ralph, actually. And this shows him measuring deflections about 9 months later, in April 1955, in the pilot bore. And he and Terzaghi find that the contractor, E.E. Black, was at fault for the deaths. And so they issue a report, and then the mayor announces that he's going to keep Black as the contractor, so he resigns. And he gets on an airliner and wants to get the heck out of Dodge and get home back to Champaign. And as the airliner is taxiing out, getting ready to take off from Honolulu International, and the police come out with lights and sirens, and they take the plane back to the terminal. They take him off the plane. You can see here, he doesn't look real happy. You ever see a picture of Ralph? That's the only picture I ever saw of Ralph, and I said to him, Ralph, you don't look too happy there. And he says, that was one of the darkest days of my life. I was being sued for $1.5 million, later went up to $3 million, and the city said, we're not going to let you go. We want you to design the tunnel, the new tunnels. We want you to do all the work, design, because you're the tunnel expert. That's why we brought you here. And we'll defend you in this lawsuit, but you got to design the tunnels. Now, college professors doesn't have time to do all the mechanical and electrical, ventilation, all the things go with designing tunnels. He's just sick. He doesn't know how he's going to get out of this thing. And they're doing this to hold him in the job. So he goes to Terzaghi, and he said, what did I do wrong? And he said, you wrote in there that the contractor was at fault. And he goes, you said that. He goes, yeah, but I didn't put it in writing. You put it in the report. You can't put things like that in a report. You'll be sued for libel, defamation of character, so on and so forth. So what happens is Ralph Burke, he goes to Ralph Burke because Ralph Burke's father was a famous jurist. He was on the state Supreme Court. He was dean for 30 years of a law school here in Chicago, and Burke had a law degree in addition to being a civil engineer. Burke takes him in. Even though he didn't go to work for Burke, Burke says, I'm going to take care of you. Everything's going to be all right. I'm going to pay for a lawyer to help watch what they're doing with you, and we're going to reassemble the whole Chicago subway team, and we'll design those tunnels for you. We'll take care of it. He said, Ralph Burke saved my life. He said, I couldn't sleep for 14 days good until that meeting with Burke. And Burke sets all this up to do it and then doesn't live to see it happen. He dies suddenly on August 30th, 1956 at age 72. Ralph is promoted to professor of foundation engineering in 1948. It's a banner year for him. He co-authors 2 papers with his father at the International Congress in Rotterdam, a dream that he had his whole life. He had 8 papers in that second international conference on soil mechanics and foundation engineering. He also published with Terzaghi, Soil Mechanics and Engineering Practice, which Reza told you about, and History of Building Foundations in Chicago, which he actually used as his textbook for his foundation engineering class till Peck, Hansen, and Thornburn manuscript was available to use in 1952. They started work on the Peck, Hansen, and Thornburn volume that year as well. Above all else, as Nancy mentioned to you, his daughter, he was a teacher, and that's how he viewed himself. He said he aspired to be a professor, and despite all the consulting he did, he was a teacher at heart. He felt that students should be inoculated with a love of civil engineering, which at its core, as you heard in his thing he wrote when he was 18, seeks to do good works for humanity. He really felt like that's what he was doing. He felt a higher calling. That's how I feel about our profession as well. That mirrors. And he said, He thought that we should educate students to be well-rounded civil engineers first and geotechnical specialists second. If you look at his, during all his retirement years, which is 34 years, he had Ralph B. Peck, civil engineer, geotechnics as his specialty. He was also registered as a structural engineer from 1943 onward, and on the State Board of Registration for Structural Engineers for over 10 years with Charlie DeLue of DeLue-Cather. So that's the end of my presentation. I will post it next week on my website if you want to download it. And there's a 40-page paper that I put that's in the conference proceedings that has all the details of the things I hit the high points on. Thank you.